Starting with earthquakes, what causes earthquakes, explaining what causes them, the energy that's released, how we measure them, and where do we locate the epicenter at. So earthquakes, the shaking that results from movement under Earth's surface. The epicenter is a place on Earth's surface directly over the focus of an earthquake. The focus then is the place deep inside where a shift in Earth's crust occurs, causing an earthquake. So remember, the focus is inside of the Earth where the earthquake actually occurs, and then the epicenter is directly on top of it on the surface. Magnitude, the number that characterizes the relative energy of an earthquake, so how much energy is being released, we use magnitude. Seismic wave, a wave produced by an earthquake. So if you remember back in waves, a movement that transfers energy through a substance, and then we have specifically seismic waves produced by an earthquake. Seismograph is an instrument that measures and records details of the earthquake. So seismograph is the actual tool that scientists use. Okay, so we have stress and faults. The movement of Earth's plates cause stress in the crust. 3 types of stress are tensional, where it's being ripped apart, tensional stress. Compression stress, compression is being smushed together, and shearing stress as it's sliding, that's our transform plate boundaries. These types of stress occur at the different plate boundaries. This is divergent, compressional is convergent, and shearing at the transform. Stress adds energy to the crust, which then bends and breaks, forming faults. And this is where the earthquakes are occurring. So that bending and breaking of the crust. Causes of earthquakes, so that's the shaking. An earthquake is the shaking that results from movement under Earth's surface. Earthquakes are caused by forces of plate movement. So that plate movement causes stress. Stress then increases along the faults, and excessive stress, too much built up pressure stress leads to rocks breaking, that breaking and bending, and that's where the earthquake begins. This is usually an abrupt movement. All of a sudden, that stress is released, and you have an earthquake. Even though we feel the effects of an earthquake on the surface, it's usually deep down about 100 kilometers below the surface. Remember, that's called the focus, which is right here. Earthquakes begin in the lithosphere, deep down, called the focus. So there are 2 centers, the focus being one of them. It's actually called the hypofocus. And so the focus is underneath where the rocks are breaking, and then the epicenter is directly above that focus, up on the surface of the Earth. I either will or have included a picture of this diagram, so I will, or you can Google focus and epicenter and look at an actual colored diagram of this focus and epicenter. So then notice from this picture, you can kind of see that there's these waves, these lines, these circles that are coming out. And we call those the seismic waves. Those are the waves produced by the earthquake. The energy that is traveling, because remember, waves carry energy as they travel. And we call those seismic waves when they're produced by an earthquake. All of these waves shake the ground. As they are going outward from the focus, they are shaking the ground. That vibrations shakes the ground. Seismic waves are classified into 3 categories. We have primary waves, secondary waves, and surface waves. Our primary waves travel the fastest. They get there first. They're the ones that compress and expand. So remember, this was compression and rarefaction when we learned about these type of waves. They travel through solids and liquids, so that means that P waves can travel through that inner core, that liquid metal layer. Where S waves, they arrive second. They move side to side, I tried to kind of draw that side to side. These are the ones that shake structures violently, that side to side action. S waves can only travel through solids. So remember the inner core, since it's a liquid metal layer, S waves cannot travel through that layer. Only P waves can. Then we have surface waves. Surface waves travel only right along the surface. They are produced by P and S waves. Okay, so P and S waves come, and then the surface waves are produced after that from the P and the S waves. They have very dramatic ground motion. If it's a large earthquake, you will actually see a wave rippling through the ground if it's a large enough earthquake. How do we measure these earthquakes? First off, Mercalli scale, that's how much damage was done during an earthquake. This is structures but also people. If more people were killed or injured, that increases the damage level of the ranking for the Mercalli scale. The Richter scale is the next measurement we use, and that's based on the size of the seismic waves. We use these seismic wave data to measure the earthquake along the fault where it's moving. We measure those using seismographs. However, we realize that it's only good for close earthquakes, this Richter scale, and only smaller ones. Once it gets too big, it's hard to categorize them into how large of magnitude it is. So on the magnitude scale, the Richter scale, if it's say like a 2 to 2.9, you're maybe only seeing hanging objects swinging. But if you creep up here to a 6 to 6.9, then you're seeing structures starting to be damaged even if they are well built. So as that magnitude is increasing, so does the damage. The newest scale that we have that was developed back in 1979 is the moment magnitude scale. They wanted a more accurate measurement than the Richter scale. So the moment magnitude actually measures the total energy released by an earthquake, and it's useful for all sizes and distances. We use data collected at seismographs to measure the magnitude of the earthquake. I would suggest you look up a picture of a seismograph if they didn't show one on the program, because there is a quiz question asking you what does a seismograph actually look like, how does it record this data. So there's a little needle on a paper, and as those waves shake the needle, it moves back and forth and records those seismic waves. Sumatra earthquake of 2004 is the third strongest earthquake. It measured a 9.1 to 9.3, somewhere around in there, on the moment magnitude scale. So that's even larger than the Japan earthquake, which I thought was the third strongest. It is actually the fourth strongest now from Sumatra. They measured maximum intensity on the Mercalli scale because it lasted 9 minutes of shaking. So even Japan, which was a 9.0, only shook for 5 minutes. Alaska shook for just under 5 minutes. So 9 minutes of shaking at this 9.1 to 9.3 is a tremendous shaking and ground movement. But then even worse is it triggered a massive tsunami. So I would suggest, I don't think I put one of the, something about this earthquake in the folder, so I'll maybe put a little video about this earthquake. Locating an earthquake's epicenter. So in order to find the actual epicenter of the earthquake, we use data from seismographs. So we usually take data from seismographs in multiple locations, and so all around the world, especially if it's a large earthquake, they will get data from around the world to try to pinpoint the epicenter and also other data that is collected. So in order to find the epicenter, you use a seismograph to measure the difference between the S wave and the P wave arrival. And once you determine how long it takes between the S wave and the P wave, then you can tell how far away that seismograph station is from the epicenter. And knowing that distance, you can draw circles by measuring the distance and with the seismograph station in the middle. So that is what is highlighted here. These seismograph stations, they use a protractor or a compass to draw circles of a specific distance around that seismograph station. Then where that point intersects, where those 3 points intersect, that is the location of the epicenter. So inside of those circles, that's where the seismograph station is. And then they draw a circle around to see where the 3 lines intersect, and that's the approximate location of the epicenter. But remember that epicenter is about the focus, not the epicenter, excuse me. The epicenter is on the surface of the earth, but then remember the focus is going to be about 100 kilometers below that epicenter. So wherever they pinpoint that epicenter, down in the earth. Last page summary. I did write a little sentence about what causes earthquakes. Remember, it's stress in the tectonic plates breaking, releasing that energy which causes shaking and earthquakes. And there is your review concepts.